Hello, and welcome to the presentation of the new network emulation feature on the Paragon-X from Calnex. The network emulation functionality has been added as a value-add feature to the Paragon-X product. What it allows you to do is, if you have a Paragon-X from Calnex, is to add the network emulation option, which delivers IP and Ethernet network realism to your testing. What that means is that you can now emulate real network effects with precision and control. Whatever your test bed, whether that's traffic or a service or a device involved in any WAN or internet type application, be that IP MPLS or the next generation SD-WAN application, you can use the network emulation function from Paragon-X to add things like latency, loss, bandwidth control, packet errors, and packet jitter, and really control this or fine granularity to actually verify the actual user or service experience. You can also capture and play back your actual network profile, so you can actually replay and test under real network conditions. Remember, this is a new software functionality that can be added on to your Paragon-X hardware unit. Let's look a little bit more about why this feature is needed and why it's useful. The big deal is quite simply that any network today it has promise of quality, performance, and especially bandwidth. So whether it's a mobile network or an enterprise or a home network, today people are promised a particular level of service, and in general they would use something like speed test to evaluate that service. So the customer expects what's promised, which is a particular speed rate, and when they run a test from home, almost no one gets what they're promised. Now this is caused by a lot of things, but one of the main drivers for poor quality of experience and poor bandwidth is the packet loss and latency that happens in a network. And the reason for this is that the TCP protocol has a windowing mechanism that means that packet loss and latency can affect the amount of bandwidth when TCP protocol is used to transport traffic. And this really happens. If you look at a real network test here where we've added emulated dropped packets and latencies with the product from Calnex, if you look at when there's no impairment, you get a 39 meg download speed. And even on the right-hand side, with just 0.1% of dropped packets, the throughput is actually down 65%. So dropped packets can have a significant impact on throughput. And so all testing of any service in an IP or Ethernet network must be done with dropped packets and other impairments. Also, it's important to add those impairments in a precise and controlled manner so that you can truly evaluate the performance of the service. The solution for the problem is, of course, to do nothing. We accept the risk and the user experience may be poor. We can, of course, use fiber reels to emulate latency and, to a certain extent, equipment to emulate loss. However, it's very big. It's very difficult to control and adjust things like latency and loss using actual network equipment or fiber. You can, of course, use freeware that's available today. However, these tests should be run at full bandwidth. That's when you see the most acute problems. It also should be run repeatably and accurately, because otherwise you can't make conclusions from the tests and you may have misleading results. So the solution is simply to add a precise network emulation device into the test bed. A service tester, for example, user traffic or protocols are emulated, the network or the system under test is evaluated, and controlled delay, jitter, and packet corruptions are added to really determine the actual service experience, the real user experience for the end users. For example, in video, when for on-demand services like Netflix or YouTube, the TCP that's used this is TCP video running, you can see some of the impact of things like latency and loss on the network, where you get this mechanism impacting the video that comes through. So this is just an example where a drop throughput will reduce the video bandwidth and will lead to buffering, which is, of course, poor quality of experience. So the conclusion here is that any network testing with traffic or packets or protocols or services should be done with controlled, repeatable, and accurate network impairments added. And the Paragon-X network emulation feature allows you to do that. And now I'll hand over to my colleague, Eric, who will run a demo using the Paragon-X network emulation feature.
Thanks, Anand. First of all, let's look at a typical customer test bed. Here we have a service tester, like the Spirent Test Center, providing test traffic into the system under test. That test traffic is used as a test stimulus, as well as to load the system as it would be in a real network. The Paragon-X is added within the system under test to emulate the effects of a real network, like latency, loss, and jitter. The effects of the real network on throughput performance and quality of experience can then be assessed. In our demo, we will use a simple setup with Test Center generating and analysing the traffic and Paragon-X adding impairments to emulate the real network. First of all, a quick look at the GUI. So this is the Paragon-X network emulation GUI. We have the normal workflow keys up the top left hand side. We start from the top and work downwards. And then we also have status LEDs in the bottom left hand corner. So these show us when the links are good and also if we're receiving good packets. So at the moment it shows us we have links up but we're not receiving any packets. Over to the right hand side of the screen we have a profile which allows us to impair traffic, and we have that in each direction. So this tab is port 1 to port 2, and in the other tab it's the opposite direction, port 2 to port 1. So this profile allows us to add impairments to all traffic in the flow at the same time. So if we had multiple streams they would all be impaired by the same amount, and we can add delay and jitter, packet corruptions, and we can also control the bandwidth. So for example we could throttle the size of the bandwidth is allowed through to 2 megs or something less. Let's go and actually connect some traffic up. Here I have the test center. Here I've created 3 streams of traffic. We've got voice over IP, video on demand, and email. And this is to emulate the different types of traffic in the network. So voice over IP is normally a high priority traffic, video on demand is a medium priority, and email is a low priority traffic. And the traffic classes is treated differently through the network, and that's one of the things we're going to show with the Paragon-X network emulation feature today. A quick look back on the Paragon-X GUI, you can see that the links are up and no packets. So let's go and add some traffic as we said. So that's the traffic started now, and if we look on the Paragon-X we should see the packet indicators go green. Okay, so we're only sending traffic in one direction, so that's why we only have one of the ports that's gone green. What we're actually doing just now, we're sending traffic from the STC and we're sending that into the Paragon-X, and it's going through this profile, port 1, and then we're coming back out the Paragon-X and coming back into the test center again. We can control the traffic being generated by test center and we can see STC results. So let's go through the workflow then. First of all, we would use startup to connect. Now I'm already connected to this Paragon on address 222. Next thing is to set up the interface. Here we have a choice of the various rates, 100, 1 gig and 10 gigabits. We can set the interface to be electrical or optical. So now we can go ahead and add some impairments. First of all, let's go and check the actual results so we can see what the setting is before we add any impairments. So if we look at the detailed streams on the STC, we can see that the short-term average latency is 40 microseconds, which is basically the intrinsic delay of the Paragon-X network emulation. So now let's add some delay on the Paragon-X. So let's add in 1000 microseconds, which is 1 millisecond. So simply type in the value in the fixed delay, and we can see that that now is illuminated in green to show that it's enabled. And then we actually start that impairment by pressing on the key here. It's gone red to indicate that the impairments are now been applied. And if you check back on the STC, the short-term average latency is 1 millisecond on each of the traffic flows. If I expand this out a little bit, we can see the flows here, video on demand, voice over IP and email. So it's 1 millisecond on each. and that's what happens when we use this mode with a single profile. We're impairing all the traffic by the same amount. Now it's quite easy to go in and now ramp that delay up. That's something that a customer might want to try, so let's just ramp that up to 5 milliseconds. Apply that change, and if we go back to the STC results, we should see the 5 milliseconds latency recorded in the results, which it is. Let's add another impairment, so this time let's add some lost packets. In the packet corruption selection sphere we have a choice of errored, lost, repeated, misordered. The most common one would be lost, so let's add some lost packets and we can make that a rate of 10%. A nice round number. Okay, so that's, we can see now that corruptions and delay are enabled here and being applied. And on the STC, if we go to the Advanced tab, we can see the 10% drop packets here. Again, it affects all three flows. And the latency is still the 5 milliseconds that we previously set. Okay, so that's a simple way to use the Paragon-X network emulation feature. It's basically one profile and we impair all the traffic by the same amount. Of course, different types of traffic are affected in different ways through the network, so what we really want to be able to do is to filter individual traffic streams and apply unique impairments to each type of traffic. And that's something we can do by using the flow wizard on the Paragon-X. So we have Flow Wizard here. If we click on Flow Wizard, we'll automatically start capturing the traffic at the ports. And then that traffic is presented to the user in a way that they can quickly set a filter to capture that traffic. So this uses Wireshark to actually detect and analyze the traffic and present to the user the flows of traffic that are at the ports. So here are the flows that have been detected by Flow Wizard, and we should be able to see the three streams that we created there. So the way I can tell the difference is that the voice over IP was on a UDP stream, so we can see here the UDP protocol. The video on demand was on a TCP protocol, we can see that there, and the email, I put that on a VLAN, VLAN ID 100, which we can see the VLAN ID 100 there. So the Paragon-X has captured all of the traffic flowing at the ports, and it's now really easy to set filters. Basically we can just choose one or more of these flows and configure the filters in that way. So let's set that down to the hardware. And now when we move back to the main GUI, so we've created three filters. We created one for voice, one for video, and one for email. And each of these filters now has a profile where we can add impairments individually to each of these flows of traffic. Okay, so I'll just clear all the impairments to start off. So one thing we have to do in the Paragon-X network emulation is if we have multiple profiles, then we need to allocate how the memory will be split across these profiles. Paragon-X makes that memory allocation flexible, so we can choose which profile should have the most memory and which should have the least. The other way we can do it is just to make them all the same. So here I've allocated 1 second on each profile in each direction. That allows us to set up to 1 second on each profile. So let's go ahead and do that. Let's on the voice flow, let's add some fixed delay here. So go to the fixed delay field and let's add 1 millisecond there. And then on the video stream, let's add half a millisecond. And on the email, let's add 200 microseconds. Okay, and let's start these impairments now. And going back to the STC results, so the short-term latency, we can, let's quickly refresh the results. Short-term latency, so on email we have 200 microseconds, on a video on demand we have 500 microseconds, and on the voice over IP we have 1 millisecond. So that shows how we can add different impairments to each individual flow. We can do the same thing with other impairments on the Paragon-X, so we can add corruptions and bandwidth control individually on each profile. Let's just have a quick look at the other impairment features. So if we just choose this profile to start with. So we can also add jitter simply by enabling the jitter here. So we can have different distributions like Gaussian, gamma and uniform distribution. So this is a Gaussian distribution. So it's quite easy to add these onto any profile in the same way we did the lost packets. We also have physical corruptions. So physical corruptions allows us to actually apply things like link flap, where we take the physical link down, or to add symbol errors, which is a coding on the layer 1 signal. So that'd be a coding error. Header overwrite is another function of the Paragon-X network emulation, and that allows us to overwrite parts of the actual packets. So for example, we could choose to overwrite certain bytes of the destination address. We can simply do that by clicking on the field, the relevant field, and adding in the values we want to have there, or we can invert the values by adding a V. And we can do that on a single basis, or we could do it as on a burst, so say 10 consecutive packets like so, or we could do a rate of any percentage, or we could have it constant, so that every packet that comes through would have these bytes overwritten. Another function is the random packet loss, and this allows us to randomly apply a packet loss in the same way as stated in G1050 spec. We mentioned the bandwidth control, and there are a couple of modes to use this in. So the basic mode allows us to control the width of the pipe. So this is useful when we want to emulate a low speed link in the network. That would say only have a bandwidth of perhaps 128 kilobits. So we can do that by throttling the pipe on this profile to say that only 128 kilobits will be allowed through. Any other packets would be dropped. The basic bandwidth control actually uses a simple pleaser and shaper, and if we want to use that in advanced mode, we also have these here. So that allows us much more control of how the pleaser and shaper will function. We also have some stats and results, which will show us exactly how many packets we are corrupting or delaying on each profile, and it will also show the bandwidth of each of the profiles, so we can see exactly how much packets or bytes are flowing through each of the profiles. Last but not least, the Paragon-X network emulation allows users to capture the packet delay variation from a live network, record that packet delay variation and store a file. Then we can import that file back into the Paragon-X network emulation feature in the lab and replay the PDV through the lab traffic. We can see the effects in the network and take them back into the lab and replay the PDV in the lab to see the effects on our traffic. So that concludes the quick overview demonstration of the Paragon-X network emulation functionality. Thanks very much.